Welcome all. I'm your host, none other than Deko Mohammed. I welcome you. Today's topic is chemistry and want to focus the cations, test for cations and anions. That's a practical question. Test for cations and anions. I still remind you, please subscribe, like and share for more free lessons. You're welcome. So, test for cations and anions, that is normally tested under practical questions. But today, I want to help you to get the layout so that when you're going to do the real practical, you have the skills. You know what you're doing. Normally, when we are testing for cations, we normally use the addition of sodium hydroxide or ammonium solution. You have to know that what happens when you're using ammonium solution, when you're using sodium hydroxide and you find out that there is white precipitate, soluble or insoluble in excess. What ions are present? The same case with ammonium solution. What happens when you're using ammonia solution and you find out that there is white PPT, white precipitate, soluble or insoluble in excess? The same case for anions. Now here on the board, I'm having a question, and also before the question, I'm also having the layout or the expectations when we have the observation and the inference. So let's start with the cations. Test for cations. We're using addition of sodium hydroxide. So here we have observation and inference. Observation number 1, white PPT. Remember this PPT, it is precipitate. PPT means precipitate, but in the examination, don't write PPT, write in full. Write precipitate because of the space. That's why I have shortened it as PPT. But if you're in an examination, write white precipitate in full. Now, if we have white precipitate insoluble in excess, there are only 3 cations that can be present. You have the barium, magnesium, and calcium. You must write the charge. Like this is 2 positive, 2 positive, 2 positive. Barium, magnesium, calcium are present when it is white precipitate insoluble in excess. Number 2, white precipitate soluble in excess. When the white precipitate is soluble in excess and we're using sodium hydroxide, then aluminium ion, lead ion, zinc ion are present. Remember, aluminium ion is 3 positive, 3 charge. Lead is 2, zinc is 2. These are the valences. If you remember, we did the chemistry, we did the valence. All these are valences, the charge, they are the valences. Now, aluminium, lead, and zinc are present when the white PPT is soluble in excess. When it is insoluble, it is barium, magnesium, and calcium. Number 3, if it is green precipitate insoluble in excess, that is ion 2. Ion 2. Ion 2 is a green precipitate. Number 4, brown precipitate insoluble in excess, that is ion 3. If it is brown precipitate, that is ion 3 present. Lastly, blue precipitate insoluble in excess. If we are using sodium hydroxide and you find out that there is blue precipitate insoluble in excess, that is copper 2 ion present. That is all about sodium hydroxides. If you go to ammonium solution, addition of ammonium solution. Number 1, white precipitate insoluble in excess. We have aluminium, lead, and magnesium. Aluminium, lead, and magnesium. Remember, if it was sodium, it was barium, magnesium, and calcium. But for ammonium, it is aluminium, lead, and magnesium. You find out the magnesium is in both cases. Magnesium is both in ammonia and sodium. Number 2, white precipitate soluble in excess. If we are using ammonium solution and you find out that there is white PPT soluble in excess, that is only zinc alone. But remember, if it is sodium, it is 3, aluminium, lead, and zinc. But for ammonium, it is only zinc that is soluble in excess. Green precipitate insoluble in excess, that is just the same, ion 2 ion. The same case with brown precipitate, that is ion 3. And also the blue precipitate that can dissolve to form a deep solution, that is copper 2 ion present. That is sodium hydroxide and ammonium solution. What about anions? Test for anions. If we add lead 2 nitrate, and we find out that the white PPT dissolves in warming. If you are using lead 2 nitrate and you find out that the white precipitate is dissolving in warming, that is chlorine present, Cl negative. present. Remember chlorine, the valence of chlorine is 1. That's why we have only negative. There's no need for me to write here -1. I just write negative. Chlorine present. Number 2, add barium chloride solution. Then you find out that there is white precipitate form. Then we have sulfide, sulfate, and carbonate. Remember, sulfide, sulfate, and carbonate can form a white PBT with barium chloride solution. Barium chloride solution can form a white PBT with sulfide, sulfate, and carbonate. Lastly, add acidified layer 2 nitrate. And you find out that there is white PBT, that is only sulfate. If you are using acidified, that means it's already added on acid. Acidified, there's a difference between layer 2 nitrate and acidified layer 2 nitrate. So this is acidified layer 2 nitrate. Then you find out that there is white PBT formed, that is sulfate. So sulfate present. That is all about the layout for test for cations and anions. What we have identified here, that there is only three ions which are colored. There are only 3 ions which are colored, which we have ion 2, ion 3, and copper, which I've written here. The colored ions, we have copper 2, which is blue, ion 2, which is green, and ion 3 brown. Those are the colored ions. That means whenever you find out a colorless solution, if you find out a colorless solution, that automatically means these colored ions are absent, which means copper 2 ion, ion 2 ion, ion 3 ion are absent because colored ions are absent. So those colored ions are absent. Having mind in that, now let's have an illustration. We see how we can apply. Remember here, I have already determined the observation because here I don't have the laboratory equipment. So I've already identified for you the observations. But once you are in examination room, you are supposed to identify both the observation and the inference. But at least now I want to give a layout such that when you're in the laboratory doing the practical, at least you have that skill that you can apply in the examination. Now we are told, illustration, we are told, you are provided with solid B. Carry out the test below and record your observation in the space provided. You are provided with the solid B. Carry out the test below and record your observation in the space provided. A, you are told, place solid B in a boiling tube. Place solid B in a boiling tube. Add about 8 cm of distilled water to dissolve the solid. Divide the solution into 4 portions. Then you have observation and inference. We have observation here, a colorless solution is formed. So you are supposed to write the inference. Number B, to the first portion, add aqueous sodium hydroxide dropwise till in excess. To the second portion, add aqueous sodium hydroxide dropwise till in excess. You have the observation, white precipitate soluble in excess. Then you are supposed to write the inference. Number C, to the second portion, add aqueous ammonium solution dropwise till in excess. Observation, white precipitate soluble in excess. Then the inference. Number D, to the third portion, add barium chloride solution. We have the observation and the inference. Observation says a white PBT formed. So you are supposed to write the inference. Number E, to the fourth portion, add acidified layer 2 nitrate solution. Add acidified layer 2 nitrate solution. This is layer 2 nitrate. Then we have the observation as white PBT formed. You are supposed to write the inference. Now let me again rewind the question. Let me repeat again for easy understanding. We are told we are provided with solid B. We don't know this solid B. We want to identify it. We'll identify it later. But we are told you are provided with solid B. Let me say this is my solid B. Then you are told carry the test below and record your observation in the space provided. So we are told that number A, place solid B in a boiling tube. Now you take a boiling tube, then you place a solid B in a boiling tube. That means you add that solid B which is provided in the boiling tube. Then you add 8 cm of distilled water. On top of the solid B, now you add water, distilled water, 8 cm cubic. Remember in the laboratory we have a distilled water which is measuring 10. which is measuring 10 centimeter cubic. Now you only go for 8. You go for 8, then you add the solid B. Now dissolve the solid and divide the solution into 4 portions. So you dissolve the solid. Once you dissolve the solid, then you divide into 4 portions. It means you take 4 test tubes. You take 4 test tubes. Let me say these are my test tubes. That means now you divide the solution into equal portion. It means equal size. So you add to the first test tube, second test tube, third, and the fourth. You divide the solution into 4. We have already taken the solid B. We have put in boiling tube. Then we have added 8 centimeters of distilled water. Now the solid B becomes a solution. Now that solution we need to divide into 4 portions. That means we are going to add into four different test tubes at equal size. Then observation and inference. What happens when you add a water in a solid? Obvious, a colorless solution will be formed. That is for sure. Whenever you add a solid in a distilled water, that is a colorless solution will be formed. And we said we only have 3 colored ions: copper, iron, and ion 2 and ion 3. Those are the only 3 colored ions that we have. If a colorless solution forms, that means these colored ions are absent. They are absent. Now we can say here, observation, we have a colorless solution is formed. Then inference we can say colored ion absent. But we have to be specific. We have to name the colored ions. So we have copper 2. You write here copper 2. Then you write ion 2. Then you write ion 3. You say present. Sorry, absent. Because it is colorless solution. And these are colored. That means they are absent. They are absent. This was still in excess. Copper 2, ion 3, absent because it is a colorless solution. Now we are told number B, to the first portion. Now, out of the 4 portions, we take the first portion. Let me say I have taken this portion. This is my first portion. Then add sodium hydroxide dropwise still in excess. If this is my first portion, now I'm going to add sodium hydroxide, which normally you are being also provided in the laboratory. So I take that sodium hydroxide, I add in first portion. I take one of the test tube. I call it first portion. Then I add sodium hydroxide dropwise till in excess. Then observation and inference. We have the observation and inference. Now we already been given the observations. We have a white precipitate soluble in excess. Remember, first, for you to form white precipitate, it means it's a milky solution. If it is a milky solution, that is a white precipitate. For you to differentiate between whether it is soluble or insoluble, this is the trick that you normally use. If it is a white PBT soluble, it will only form one layer. That means that milky solution will only have one layer. But if it is insoluble, it will form different layers that we will see. Out of the milky solution, you are going to see different layers. I wish I had the equipment. I could have shown you, I could have demonstrated, but I don't have the laboratory equipment. But at least we have that skills. Once we are going to do the real practical, at least you can apply it. Now, for this case, it is soluble in excess. That means our milky solution was forming only one layer. That's why we have here a white PBT soluble in excess. Then we have now known, because this very helpful. They are very helpful. We are using sodium hydroxide and we are told soluble in excess, white PBT soluble in excess. So we are going to pick these three cations: aluminium, lead, and zinc, because it is sodium hydroxide, and we find out that there is white PBT soluble in excess. Now we come and say here in the inference, we come and say we have aluminium ion, we have lead ion, then zinc ion present, because it is sodium hydroxide and it is soluble. aluminium, lead, and zinc present. Then, to the second portion, add sodium hydroxide dropwise still in excess. Remember, we have divided the solution into 4 portions, into 4 test tubes. We have already used 1. Now we go for number 2, to the second portion. Now we are not adding sodium hydroxide, but we are adding ammonium. Now the second portion, now I add ammonium. What happens now? From the inference we are told it is white PBT soluble in excess. And from the layout, we have the white PBT soluble in excess. We only have zinc. If it is ammonia and the white PBT is soluble in excess, then it can only be zinc. So we say here zinc present. Come and say here zinc present. Before I go to the third portion, before I go to the cations, before I go to the anions third portion, there's maybe some instances. You may find out, let's say like this. This was the case. Let me say we are using sodium hydroxide. Then you find out that white PBT insoluble in excess. You find out that is let me say we are using sodium hydroxide and we are told white PBT soluble in excess. If you are using sodium hydroxide, then here we have white PBT soluble in excess. Obviously, we are going to write aluminium, lead, and zinc. Aluminium ion, lead ion, zinc ion present. Again, let me say to the second portion now we are using ammonium, NH4 positive. Let me say to the second portion we are using ammonia. If we are using ammonia and let me say it has we found out that we have white PBT insoluble in excess. White PBT insoluble in excess. If we are using ammonium hydroxide and white PBT insoluble in excess, we have 3 options: aluminium, lead, and magnesium. Aluminium, lead, and magnesium. If you write aluminium, lead 2 positive and magnesium 2 positive, if you say present, this is wrong, because we know that it is aluminium, lead, and magnesium, but here we have already written that it is aluminium, lead, and zinc present. Now we can't introduce a new cations. That means whichever the case, even if it is so insoluble in excess, we have already identified these 3 cations: aluminium, lead, and zinc present. Now we are not supposed to introduce any other cations. For this case, when it is ammonia and it is insoluble, we have aluminium, lead, and magnesium. We can't use magnesium because it was not present in the first case. Now we are going to remove magnesium. You only say aluminium and lead, lead present. Aluminium and lead present. That's the trick sometimes the examiner they use. You may find a student introducing a new cation which was not in the first case. You are not supposed to introduce a new cation in the first case. That was, by the way, I was just illustrating. Now let's continue with our question. Number C. To the second portion, add aqueous ammonia dropwise still in excess. Sorry, I've already done that. Number D. To the third portion, add barium chloride solution. Barium chloride. Now we are testing for anions. Add barium chloride solution. And in the observation we have a white precipitate form. Remember? Here is the case. We say barium chloride. When we are using barium chloride and white PBT formed, then we have sulfate, and carbonate present. Sulfate, and carbonate present. So now you can say sulfite. You can have sulfite. You can have the sulfite. Sorry. Let's have the sulfite. Then we have the sulfate. Then carbonate present. Lastly, to the fourth portion, add acidified lead nitrate solution. Then observation, we are told a white PBT form. That is the only case we have written here. Add acidified lead nitrate. If we have white PBT, that is sulfate. That is sulfate present. Sulfate present. That is all about this class. I was just brief introduction of test for cations and anions. What you have to know is that what happens when using ammonium hydroxide and also sodium hydroxide when the white PBT is soluble and insoluble. I hope you enjoyed the class. Thank you for watching. May God bless you.